I want to refer to this image and the various differentiation pathways resulting in the formation of a red blood cell or an erythrocyte, a platelet or thrombocyte, a neutrophil, eosinophil and basophil, a monocyte and lymphocytes. It's a rather simplistic view of the differentiation pathways, which would be more extensively explained in a hematology course, where a deeper knowledge and understanding would be more appropriate and an essential learning requirement. The original stem cell that gives rise to all the lineages is called the hemopoietic stem cell. It's a pluripotent stem cell, and obviously a very important cell. It sits in the bone marrow. This stem cell divides over and over again and gives rise to the progenitor cells, which, in turn, go through the process of providing lineages leading to the production of all the different blood cell types. You can imagine then how important it is that this hemopoietic stem cell divides continually to provide these progenitor stem cells, as their numbers disappear during the process of their differentiation into the final blood cell types. A number of different colonies arise from these hemopoietic stem cells. One is the common lymphoid progenitor cell line that gives rise to the lymphocytes. Then there are the rather common myeloid progenitor cells, which are different progenitor cell populations that are then influenced by a number of factors that stimulate these lineages to go through various processes of developing into erythrocytes, the process called erythropoiesis, megakaryocytes and the platelets, the process called thrombopoiesis, and the white blood cells, the process is called leukopoiesis. Several other types of cells may also form in bone marrow, such as mast cell precursors, but are impossible to distinguish. To identify individual cells of marrow, to recognize their lineage, and then estimate their developmental stage is extremely difficult, and I'm going to avoid this. The more juvenile cells can look very much like one another. You can pick out such cells because they're large with pale nuclei, but it's impossible to name most of them. Keep in mind that an important function of bone marrow is to store mature white cells in addition to forming them. In this lecture, I'm going to concentrate on showing you stages of erythropoiesis, manufacturing or giving rise to red blood cells, and leukopoiesis or granulopoiesis, giving rise to the granulocytes, of which only the neutrophil is going to be the example I'm going to use. And quite frankly, even though I will attempt to show you some of these early cells in the differentiation pathway highlighted in red text, I am not entirely convinced of my choice. But it's understanding the morphological changes one would expect during the pathways that best suits this histology curriculum. And so I'll make sure I clearly outline the morphological characteristics of each step in the differentiation process, and if possible, show you examples in the images.